Hey everyone, today we are going to solve the daily LeetCode problem of 1st January 2024. So the problem is assign cookies. So let's first understand the problem statement. So according to the problem statement, we have two arrays, G and S. Let the element of G be 1, 2 and the element of S be 1, 2, 3. Now each element of G represents the minimum size of cookie that we need to provide a child to satisfy his greed. So it's the minimum size of cookie to satisfy this child. So it means that we need to provide a cookie of size 1 to satisfy this children. And we need to provide a cookie of size 2 to satisfy the children at index 1. Now, each element of S represents the size of cookie. So it means that we have a cookie of size 1, we have a cookie of size 2, and we have a cookie of size 3. Now, our goal and what we need to return is that how many children, what's the max number of children that we can satisfy. Now, what is the condition to satisfy a child? So the condition is that if a greed of child at ith index, let us consider that this is the greed of a child, if his greed is lesser than equal to the cookie assigned to him. So say for example that I want a cookie of size 2 and I have been given a cookie of size 3. So I was expecting a cookie of size 2, but I have been given a cookie of size 3. So it is greater than my expectations, right? So I would be satisfied, or I would be happier to get a cookie of a greater size. Or even if I have been given a cookie of size 2, still I would have been happier because I wanted a cookie of size 2 and I have been given a cookie of size 2. So we need to return that what's the number of children that we can satisfy. So let's say in this example that we have that the grade of this child is 1 and the minimum size of this and the size of this cookie is also 1. So we can assign this cookie to this child. And similarly, the greed or the minimum size of the cookie required to satisfy this child is 2. And we have a cookie of size 2, so we can assign this to this child. So we are able to satisfy 2 children. So what should be our approach? Let's understand this with another example. Let's say we have G as 1, 4 and S as 7, 2. So we can see that the grade of the current child is 1 and the cookie available to us is 7. So we can satisfy this child by assigning this cookie to this particular child because he was expecting a cookie of size 1 and we have given him a cookie which is greater than his expectation, so he would be happier. So we have the count of satisfied child as 1 as of now. Now coming to this point, so can we assign this 2 to this 4? The answer is no. Why? Because he was expecting a cookie of at least size 4, right? And this 2 is below his expectation, so he won't be happier, right? So our answer is 1 in this case. But is this right? So the answer is no, this is not right. Why? Because we could have assigned it in a different way. So let's see what it could have been. So G is 1, 4 and S is 7, 2. So we can see that the grade of this child is 1 and this cookie is of size 2. So this 2 is greater than its grade. So if we assign this 2 to this 1, he would be happier, right? So our satisfied count is 1 plus. Now, since we have assigned this cookie and this has been child has been satisfied, so let's move to another one. Now the grade of this child is 4 and this cookie is of size 7. So we can assign this 7 to this child because this size is greater than his expectation. So he would be happier and satisfied. So our satisfied count is 2. And this is the correct answer and the optimal one. So while assigning the cookie, we need to keep one thing in mind is that we need to assign a particular child the cookie with the smallest size such that it can satisfy him. and we are not using any greater cookie like to waste it. Now, what do I mean is that, say for example, I have a cookie of size, say for example, the greed of a child, say for example, the greed of any ith child is 2, and I am having two cookies. Say for example, one is of size 2 and the another one is of size 7. So which one should I assign to this child, 2 or 7? So the correct approach would be to assign this 2. Why? Because there could be a possibility in future that there is another child which has a grade of, say for example, 4. So we can use this 7 to assign to that particular child, because if we would have assigned this 7 to this child, so this child would have been satisfied, but we won't be able to satisfy this child because his expectation is 4 and we are left only with 2. So we should keep in mind that we are only using the smallest cookie that can satisfy a child, so that the cookie with a greater size can be left to satisfy another child with a greater expectation in future. So how we can achieve this? So what we can do is, let's see another example. Have greed array as 4, 2, 3, 5, and 6, and the size array as 1, 2, 4, 7. So to achieve the fact that each child has been assigned the smallest cookie to satisfy him, what we can do is we can sort this grade array as well as this size array. So we'll have 2, 3, 4, 5, 6 after sorting this grade array, and after sorting this size array, we'll have 1, 2, 4, 7. Yeah, that's all. So we can take two pointers, one pointer as the grid and another pointer at that would iterate over each element of the size array, right? So let's index them 0, 1, 2, 3, 4. Let me put these index above, right? Since there is no space here. 0, 1, 2, 3. Okay. So now we will check that can this cookie satisfy this child? So we can see that the expectation of the child is 2, but the cookie size is 1. So we can't satisfy this child with this cookie. So we'll simply move forward to another cookie. Now you can see that why we are moving only this pointer and not this pointer. The reason is that each of the element present after this 2 are greater than 2, right? Because we have sorted it. So if a cookie, so say for example this cookie, so if a cookie is not able to satisfy this child, then how it can satisfy this child, right? Because this one is comparatively greater than this, which is obvious. That's the reason why any cookie that we are present, so that cookie need to satisfy the current child, then only it would be able to move to the next child, because the next child has a great expectation. So if it can't satisfy the current one, it can't satisfy the next one as well, right? So now we'll check if this 2 can satisfy this the greed of this child. So since this 2 is less than equal to 2, so this can satisfy them. So we'll move, so this child is satisfied, so we'll move this pointer here, and this cookie has been used, so we'll move this pointer here. Now we'll see that can this cookie satisfy this child? So since 3 is lesser than equal to the available cookie size, so yeah, it can be satisfied. So this child has been satisfied and this cookie has been utilized. So we'll move both of these pointer ahead. Now we'll see that can this cookie satisfy this child? So yeah, the available size of the cookie is greater than the expectations, so it can be satisfied. So we'll move this pointer ahead and we'll move this pointer ahead. Now we'll see that we have completely exhausted the size array. We don't have any more cookies left, so we can't assign any cookies to any of the child, right? Now we can see that how many children we were able to satisfy. So it's 1, 2, 3, which is nothing but the the index of the children that we satisfied plus 1. That is up to 2 index we were able to satisfy the children plus 1, which is 3 is the answer. Let's code down the solution. So let's start by sorting both the array. I would first change the name of the array as greed and this as size of cookie. Okay. or we can say like cookie size. Yeah, this is better. Now for sort, let's sort this array. So we can do sort greet dot begin, comma greet dot end. And similarly, we have to sort the another array as well. Cookie size dot begin, comma cookie size dot end. Now, after sorting these two arrays, let's take the two pointer, which is like current child. This current child pointer represents the particular child in the greed array. And let's take another pointer, which would be current cookie. So this current cookie pointer represent the current cookie in the cookie size array, right? Now let's iterate over both the array. So we'll say like while my current child is less than greet.size, and while my current cookie is less than cookie size dot size. Okay. Now, what we were doing here is that if we were able to satisfy a child, like let's see here, if we were able to satisfy this child, we were moving both the pointers ahead, right? So if greed of current child is less than equal to cookie size of current cookie, in that case, what we were doing is we were moving both the pointers, right? So what we were doing is we were moving current child as well as we were moving current cookie. Otherwise, what we were doing, like say for example, like here it was 2 and here it was 1. So 1 was not able to satisfy 2. So we were simply moving this pointer ahead, which is current cookie pointer ahead. So else what we'll do is, else we'll move the current cookie. So you can see that, sorry, I have mistaken this. I forgot to put this plus plus. So you can see that we are incrementing this current cookie in both the cases, in the else case as well as in the if case. So what we can do is we can simply remove it from here, right? And we can simply put it over here. So if a child has been satisfied, we are moving it, we are moving on to the another child. Otherwise, we are simply moving to the next cookie. And like if a child has been satisfied, so we are also moving to the next cookie, right? And in the end, we need to simply return current child. Why we are returning current child is C. In this case, we can see that after we have satisfied this child, right? After we have satisfied this child, we are incrementing this, right? We are incrementing this 2 as well. So yeah, this is the code. Let's run this. This would be cookie size dot end. Now let's run this. Let's try on all the cases. Let's submit this. About the time complexity and space complexity. Time complexity and space complexity, right? So here we can see that we are, we are first sorting the grid array. So say for example, if we have the size of grid array as n, and we have size of cookie size array as m. So we can see that here we are sorting the grid array, and we know that the sort algorithm takes order of n log n. So if the size of grid array is n, so here we are having big O of n log n as the time complexity. Similarly, here we are having the time complexity is order of m log m, right? And additionally, here we are iterating over both the arrays, which is the grid array as well as the cookie size array. So here we are having a time complexity of order of n plus m. So overall time complexity would be nothing but order of n log n plus order of m log m. Now talking about the space complexity. So this sort algorithm in case of C++, it takes order of log n. So in this case, since we are using the sort algorithm for two of the arrays, one is of size m and the another of size m, so it would be order of log n plus order of log m, which is nothing but order of log n plus log m, right? Like in case of C++, it uses quick sort, heap sort, and insertion sort behind the scene, and which takes some additional spaces, which is in generalized way, it is log n. So since we are sorting two of the arrays, so it would be log n plus log m. So that's all for today's daily LeetCode problem. Thank you.